All right, let's start taking a look at these. So we're asked to find the inverse on these. And on this first one is y equals 2x minus 1. How do we start that process? How do we find an inverse? We take our x, we take our y, and we have them change places. So the process of finding the inverse means I'm going to take the letter y, and I'm going to take the letter x, and we make them change places. So we would write this as x equals 2y minus 1. But we don't typically write equations as x equals. So the next thing we have to do for our inverse is we need to fix it to be a y equals. Because this is technically the inverse function. It's just horrible, horrible, horrible math grammar. What do we do to get our y by itself on this one? How can I get him by himself? We will need to divide by 2, but what should we do first? Add 1. I was going to say, if we don't add the 1 first, it just makes things a lot more fractiony. And we usually get a little uncomfortable with that sometimes. So you absolutely can do the divide by 2. It just makes things a little bit harder. So we get our x plus 1 equals 2y. And then when we divide by 2, because that's absolutely the next step, we can either do it as one big divide by 2 like this, or you can come in and divide by these two things individually, like this. Either way is fine, and we're going to get that our inverse of this equation is our x plus 1 over 2, or x over 2 plus 1/2. I'm going to do the x plus 1 over 2, because I'm not graphing this thing. Either way is fine. So this is our inverse for this first equation. What do we do on the second one? How do I find an inverse on this guy? What's our first step when finding an inverse? Have them switch places. Take my x and my y and have them switch places. Literally just the letters. So my x and my y are going to swap spots. So our inverse is going to say x equals y squared. How do I get the y by itself to get this back into be something that's a little less gross? We got to get rid of that square. How do I get rid of that square? What's it called? Square root. All right, my 1, 2, 3, 4, 5 friends that are focused entirely on our phones right now. I want to put those away. So that gives us that our square root of x equals y. That's our inverse. On this third one, I tricked you a little. I tricked you a little bit. We're still going to do the same process, but then we're going to look at it for a second. Because we've got our x and our y that we change places. So this says x equals 3 to the power of y. We can't do like a y-th root. That would be weird. This is what we're headed into in our next chapter. To be able to solve something like this. So be able to take these exponential functions that we've been working with, that 2 to the x, 3 to the x, whatever, and to be able to find the inverse, because we get stuck right here. This isn't something we can do right now. We don't have the tools for it. But that's what we're headed into. That's why we start with the inverses, and then we do the exponentials, and then we try and do it here, and we go, ew. So that's what we're headed into. And this chapter, since it's kind of like finicky little details, and it's a little bit long, and it's going to like straddle across spring break. We're going to have a chunk beforehand and a chunk after spring break. I did it. I mean, you don't have to use it, but I did a nice. And I made the notes for the whole chapter as a packet, so that you don't have to write everything out all by hand. You can, absolutely fine. If you want to do it by hand, more power to you. But that way it makes things a little bit easier to keep organized when you have it split over spring break, because all your notes are in exactly one place. So this is for the whole chapter. The whole chapter has these, so please put your name on the front because I made like 3 extras, and you don't want to have to make extra copies of this gigantic package. Okay?
Too many trees.
It's a lot of trees. I will get there. I genuinely do not remember off the top of my head. So put your name on it, and I'm going to test this. I believe it's in April. I know that much because we go across spring break. And April 16th will be when the test is.
That's my best friend.
Oh, well, congratulations to your best friend. Okay, so what we're going to be working with are things called logarithms. So this has a lot of stuff in here. We're going to do all kinds of things, and we're pretty much going to use every page in the packet.
That guy's arm looks concerning.
It's kind of coming out of the wrong side. I think it's meant to be this, but it's still weird.
Oh, God.
But to be fair, I did not pick that clipboard. So, we're going to look at some stuff, and we're going to get through. We might get all the way to here today, but we should get at least to here. Yes, sir. I'll post my digital copy just like normal. Yeah. But that way it's honestly going to be easier because you'll have the problems available to you right there. So what we're going to be working with is called a logarithm. And what a logarithm is just like the square root undoes squaring. A logarithm undoes the exponential function, so it is the inverse of an exponential. So for what is a logarithm, this is on that very first page, it is the inverse of an exponential. Thank you, dear. I gave a notes packet for this chapter. So this is the inverse of an exponential function. It undoes exponentials. I'm going to fix that L so it's actually standing up properly. And the reason we have logarithms, for the why we have logarithms, we saw that in the bell work. It's so that we can get variables out of the exponents. We didn't have any way to get this y out of here. So the reason we have logarithms is to get variables out of exponents. So we're going to write a couple of things here for our logarithmic function rule, domain, and range that are going to feel a little bit Greeky. When we get to working with them, I promise I will tell you what every single piece means. But like we're going to put it here so you have it on a front page. It's nice and easy to find if we need it. So our logarithmic function rule, it's fancy talk for our equation. That's our y equals a times. We're going to write the word log. Oh, my pen's going to freeze. There we go. Like literally the word log. I almost always loop my L when I write the word log just so it simply doesn't wind up looking like 10G. But as long as you know it's log. But log, and then we put a little b down kind of by the loop of the g. So it has a base, and we put it as like a subscript is what they call it in like texting, text formats. So we have a log base b, but it like shrinks and goes down. And then we're gonna have x minus h plus k. We will work with graphing this stuff eventually. I believe actually ended this week. But we see a lot of very familiar friends in here. We have our A, we have our H, we have our K, we even have our B that we started looking at last chapter. Same pieces, same guys. For our domain on logarithms, it's either going to be from H to infinity, or it's going to be from negative infinity to H. Those are our two options. And range is always going to be negative infinity to positive infinity.
So it's like the opposite of the last chapter.
It's almost like it's an inverse of it. Yes. Oh my gosh, what? Yes. It's because it's the inverse. And honestly, when we look at working with graphs and stuff, that is 100% going to be how we do it. It's a note packer for this chapter. So it's going to be one of those things that's based really heavily off of our exponential functions. Mm-hmm. Okay. So our next pieces that we're going to have is that every single logarithmic function is going to have a vertical asymptote. Our exponential functions had a horizontal asymptote. Went this way. Every logarithmic function has a vertical asymptote. So we still having asymptotes here. Asymptotes. Oh, it's just going to have one. Understood. It's a sleepy day out. And then we're going to have two special important logarithms that we're going to need to know. And the first one is called the common log. And that means it has a base 10. And we have two different ways we can write it. We can either put it as log with a little 10 right here. Or more often than not, when we have the common log or log base 10, we just put log with no little number. The other one we're going to see is called the natural log. And what the natural log has as a base, it has a base of E. That guy from the last chapter from PERT, E. And we can write that as log base E. But again, more commonly, we put this as ln. Like that button we pushed to get to the E on the calculator. How E was the green button and then the ln button. That's because our natural log base E is ln. It's related. It was not randomly chosen. And I know that this is Greek and we're going, I don't know what this means yet, but having all of this information be on that front page will be helpful if we're trying to figure out what the heck does this thing mean again. This is kind of our everything in one place spot. Okay? So I know it felt like we just wrote a whole lot of stuff. We have no clue what that was. That's okay. That next bit where it says exponential form versus logarithmic form, that's where we're really going to start figuring out what the heck is happening here. Kind of. It's gonna feel very, very weird. Okay? This is just kind of like filling in a reference page so that we can see it and have all the things in a very similar place. But this is kind of our big ticket for today. So our exponential form versus our logarithmic form is where we're going to start. And what we have for exponential form is we're going to have something that is a base to some power is going to equal, we're going to call it an argument. So B is our base. P is a power of some sort, of an exponent. And we call A the argument. And what we're going to do is we're going to be able to switch it to something called its logarithmic form. So these two things are equivalent, they're just going to look different. And the way we can write it is we're going to put logarithmic form is going to be log, that's going to have a base of b, it is small, it is below. If I wrote these on lines, it would have made way more sense. So like, normally we write it on a line like this. But it's log base b, and then it's going to have another number behind it of a equals our power. So what's happened is what was an exponent is now kind of in the main line of the problem. And it's going to be something that we can solve for. But our BPA log BAP. BPA log BAP. Okay. This is honestly going to be the thing we use the most frequently in this chapter. BPA log BAP. You can get real sick of hearing me say it. BPA log BAP. You're going to use it a bunch. Okay, so the first thing we're going to do is we're going to take some logs that I give us, and we're going to switch it from log form. It's going to give it to us like this, and we're going to rewrite it like this. So we're just going to switch the pieces. We play match them up. So we're going to rewrite these into exponential form. I'm going to put my little BPA log BAP at the top. So our BP, A, we are going to switch to, from log BAP, log base B of A equals P.
So we're only doing 1, 2, 3, 4, 6, and 12.
We're going to kind of bounce around. I picked my favorites. I might have y'all try more, but we're going to see. We're going to see how this goes. So what we're going to do is we're basically going to play match them up. So we're giving you one of these pieces. On number 1, we're looking for that B, our base. It's this little guy right here. So on this first one, we have a base of 19. When I'm writing it in exponential form, the next piece I want is actually my power, so I want my P. Power is over here. Power is going to be 2. So this is 19 squared. That's going to equal my argument. A is this guy in here. This 361. So what log base 19 of 361 equals 2 means is that 19 squared equals 361. They mean the same thing. It's just taking our power and making it be as a like mainline number. Same kind of vibe for number 2. I'm going to find my base, which is 7, and my power, which is that 3. And we know that's going to equal our argument, which is that 343. So log base 7 of 343 equals 3 is the same thing as 7 cubed is 343. So for number 3, what's my base? 15. What's my power? 2. And we know it's going to equal our argument, which is 225, the only piece we have left. So it's all about switching the pieces. Bless you. So for number 4, what are we going to have when we switch this back to exponential form? Oops, sorry, wrong pen. So we've got our 18 to the what? One over 324 is my A. So we get 18 to what power? To negative 2. 18 to the negative 2 equals our fraction, that 1 over 324. And you can type that in the calculator and see that that is in fact true. 18 to the power of negative 2 is 1 over 324. Just like 7 to the third is 343. These are true statements. How about for number 6? What do we get? How do we put that in its exponential form? 2.
To the power of 0.
To the power of 0
equals 1.
Which again is a true thing. 2 to the power of 0 is 1. Anything raised to a power of 0 is 1. 12 is a little tricky, but I want us to look at it because it doesn't have a base written out there. That was to say, look just a little bit above on your page. If we do not write a base in our special logarithms, what is the base? If it just says log. 10. If it just says log and there's no little number here, it's an invisible 10. Because that's called the common log. It's this guy over here. So if it just has log, no base, it is the same thing as log base 10 because mathematicians are extra and like to make things complicated for absolutely no reason. It is also one of only 2 logarithms bases that are programmed into the calculator. We can do log and we can do ln. Those are the only ones we can type in the calculator right now. We can't type in any other base. So writing this in its exponential form, when we have log of 100, common log, that tells me that my base is 10. What's my power? 2. And my argument, 100. Okay. So I know we have a whole bunch on here, but there's just a few that I really wanted us to see. We're not necessarily going to do every single problem in these packets, but like we'll bounce around. So now we can switch from our log form to our exponential form. Now we're going to go the other way. So we're going to write each of these exponentials into logarithms. So I'm going to put our form up on the top. That was our B, P, A. We can switch it to our log BAP. Log base B of A equals P. So when we're filling this out, we're going to, again, play match them up. I know my base for number 1. Our base is 5. My power is 0. And my argument is 1. It's matching up directly with each of these pieces. So to write it over here in our log form, we're going to put our log with our base of b. So in this case, we have a base of 5 of our argument, which is 1, equals our power, which is 0. It is very, very important that your base is both smaller and lower than your 1. Yes, my dear. Oh, yeah, give me a second. So it is very, very, very important that your base is smaller and lower than your argument. If I put log 5(1) on the same line, that does not tell me log base 5. You have to count log of 51. So your base has to be smaller and lower. So look at our next one. We have e to the x equals y. Switch this around in the long form. See what we can do. So what is our base for number 2? E. What is our power for number 2? X. What is our argument for number 2? Y. So we've got our base, our power, and our argument. So when we write this, I'm going to just write it out the normal way where we have our log with base E of our argument, y, equals that power, x, which is 100% a valid way to write it. We can also notice that, hey, that was one of those things we wrote, log base E. We can also write this as log base E, we can write as ln. And that does our log and the base. So ln of y equals x. Those two things are equivalent. Log base E and ln mean the same exact thing. They're just writing it in 2 different ways. Again, mathematicians like to make things complicated. Thanks, history. So let's practice this with some more normal numbers again. But I just wanted us to see the ln thing. And if we write it like this, 100% okay. 100% okay. We'll get more into why we have that when we need it. I'm 100% okay with us doing it right here, especially at this point. So for number 3, very similar vibe. We're going to have our log with what base? Log base. What is our base on this one? 16. So log base 16 of what argument? What's our argument? Oh, I heard it. It was very quiet, though. It's 256. Equals what power? 2. Okay, so I know it feels like we're just doing things for absolutely no reason. I promise there's reasons. Okay, so let's do a couple more of these. So for number 4, we're going to have our log base. What's our base? 4. Log base 4 of 1/16. Wrong color. Trying to keep things consistent. Equals -2. I'm going to do 2 more in this section. I'm going to do 5 and 6. Okay, so for number 5, we're going to have log base what? Log base 5. Of our argument, which is 125, yep. And that's going to equal our power 3. Oh, that is all in blue. There we go. All right, last one like this, and then we're going to see why the heck we care. Kind of. Ooh, wrong pen. That was a highlighter. That was chonky. All right, so for number 6, we get log base, what? 13 of 1 over 169 equals -2, our power. Okay, bless it. So when we first start looking to solve these, the whole thing we're going to do is we're going to switch them and we're going to figure out what value fits. So we're not going to be doing tons of like calculation right off the bat. It's going to be mostly logic on these. So if we look at the next couple, that's where we're really going to start tomorrow by looking at them and switching the forms. So we're just starting with switching things back and forth and working with that. Tomorrow we'll get into that next section down into the story problem part. Okay? So these are awkward, these are weird, and they are uncomfortable. And that is normal. Go for it.
Are we not going to do
The rest of them?
yeah.
I do not have planned for us to finish them out, but they are wonderful extra practice for you. If this is something we have no clue what the heck gibberish just happened, there's a few more extra practice problems in there. And that's going to be kind of how it works throughout most of the chapters, that there will be some extra practice kind of in the packet, just because I'd rather have too many problems in there and be able to skip a few than need to try and squeeze a couple extras in. So, I have the first homework for this chapter. This first homework covers a lot. So, it's got what we did today, what we're going to do tomorrow, and what we're going to do on Wednesday for sure, probably Thursday as well. So, I have it due on the 21st, which I believe is Friday. Mm-hmm. Yeah, due Friday. So, this has like 4 days of stuff on it. So, I'm going to pass it out. You guys can do 1 and 2.
That's it.
Well, they each have 3 on there. So if you want to finish out the rest of the packet, I always do have the answers for all of those extra questions in there as well. And you're always welcome to check it.
Finish out the rest of the packet.
That's going to, like, I was not packet, like the set. I was going to say, we're going through the whole rest of the packet together. That packet's going to last us all the way through middle of April. Please don't lose it. All right, April 16th is when our chapter test is. We are going to have a skills check right before spring break, though. Okay, so we're going to skills check on the 26th. And we've got like 3 minutes till announcements. So, yeah. I do have the chapter tests graded and in. If you would like to see yours, let me know. I can get it out.